We shall see some of the concepts in BJT, bipolar junction transistor. BJT, bipolar junction transistor, is a 3-terminal device. We have emitter, base and collector. So we have PNP transistor or NPN transistor, which has emitter, base and collector. So this is emitter terminal, base terminal and collector terminal. So the emitter current is IE, base current is IB and the collector current is IC. The emitter current IE is equivalent to the base current plus the collector current IC in magnitude, and it's different in direction. So for NPN transistor we need to give for the emitter base. So here for the transistor it may work as either amplifier or it can work as switch. For the transistor to work as amplifier, the emitter base junction must be forward biased and collector base junction must be reverse biased. So this emitter base junction should be forward biased, means this emitter should be connected to the positive, P connected to positive, N connected to negative. This is forward bias. So here reverse bias, so N connected to positive and P connected to negative. Same way here, N connected to, this should be forward bias, so negative and positive. This should be reverse bias, so P connected to negative and N connected to positive. So here the ratio of the total width to the center layer is 150:1, which means the total width if it is 150, the ratio to the center one base is 1. So by size, the base is the smallest compared to emitter and then the collector. Compared to doping, collector is more heavily doped than the emitter, then the base. Base is very lightly doped, collector is heavily doped and the emitter is moderately doped. So we have here 3 types of transistor BJT: common emitter, common base and common collector configurations. So here in NPN transistor, the transistor diagram is like this. The PNP transistor, the arrow mark goes outside is NPN transistor. So this is NPN transistor. So this is emitter, base and collector. Arrow mark goes outside, which means the emitter current is going outside in emitter transistor, base current IB is going inside and collector current IC is flowing inside the transistor. PNP transistor, arrow mark points inside, which means the emitter current is flowing inside. This is base and collector, and this is a PNP transistor. We have 3 types of configurations: common emitter, common base and common collector. So common emitter, common base and common collector. So the common terminal, we have common terminal, input terminal and output terminal. Common terminal is also the grounded terminal. So in common emitter is grounded, input is in base and output is in collector. In common base is grounded for common terminal, input is in emitter and output is in collector. Common collector is grounded, input is base and output is emitter. So we have the common base configuration. So common emitter, so first we'll see about common emitter configuration, where the emitter is grounded, input is in the base and it is emitter base junction forward biased and collector base junction reverse biased. So this is common emitter configuration, emitter, base and collector. So common base configuration is base is grounded, input is emitter and output is collector. And common collector configuration, collector is grounded, output is in emitter, and input is base configuration. And in all the places IB, this is IE and IC. The emitter based junction is forward biased and collector based junction is reverse biased. So when we start with common base configuration, so the base is grounded, input is emitter and output is collector. So this is the base current IB, this is the emitter current IE, NPN transistor. Emitter current goes inside, base outside, base current and collector current goes inside the transistor. Here we have an ammeter to measure the emitter current IE, a voltmeter VEB because it's between base and emitter, and the supply here biasing is given by the V, it's an emitter side, so it is VEE. Same way in the output side we have an ammeter to measure the collector current IC, voltmeter to measure the VCB, and then the biasing here, and VCC is the voltage supply given here. So here again emitter, base and collector. The emitter base junction is forward biased and collector base junction is reverse biased so that the transistor may work as an amplifier. So we need to draw the input characteristics and output characteristics. Input characteristics is drawn for the input voltage VEB and input current IE, keeping the output voltage VCB constant. So for different VCB the curve is drawn. So this is for VCB equal to greater than 1 volt and VCB is equal to 0 volt. So this is like PN junction diode in forward bias only when VCB equal to 0 volt. This is the VCB voltage, no? So when VCB voltage is 0 volt, so it's like a PN diode in forward bias only. So we have the forward bias characteristic. And as we increase the VCB voltage, the curve shifts towards the left hand side because of base width modulation or early effect. So early effect or base width modulation is in reverse biased PN diode. As the reverse bias voltage is increasing, the depletion width between this base and the collector increases in the reverse bias voltage. So when the depletion width here increases, it's the same region, this region can't increase, so the base width reduces, and as we increase for a higher reverse bias voltage, the base width becomes 0 itself, and so all the electrons goes towards the collector and we get a higher voltage. So amplification here is transistor, it is transfer of resistor. The movement of the low resistance region goes to high resistance region. The electrons here, less recombination happens in the base here and we get a base current IB, and most of the remaining 95% electrons goes to the collector side and we get the collector current IC. This is what happens in transistor. Because of early effect or base width modulation, there is less chance for recombination within the base region, and so alpha increases. Alpha is the current gain for common base transistor. So alpha is equal to output. Alpha is the current gain, so it's output current by input current. So IC by IE is alpha. So alpha increases from 0.98 to 0.985 in case of common base. So as this region, the base width reduces and finally becomes 0 itself, no? That is called as punch through. So this is about input characteristics. For output characteristics, it's drawn for the output voltage VCB and the output current IC for different IE values, input current values. So for different IE values, we have the output characteristic curve like this. So it does not depend more on VCB. So this is for take IE equal to 5 milliamps, IE equal to 4 milliamps, like that it goes on. So it's nearly parallel to the VCB line, which means it is not more dependent on VCB. So there is no resistance also here. And we have 4 H parameters for common base transistors. So they are the input impedance HIB, which is equivalent to del VEB by del IE, keeping VCB constant. The value is nearly 20 ohm to 50 ohm. It's the slope of the common base input characteristic curve. It's input impedance and it is for common base, so it is HIB, impedance voltage by current. And then output admittance HOB equal to del IC by del VCB, keeping IE constant, and this is the slope of IC versus VCB curve. The value is from 0.1 to 10 micromhos. It's output admittance, so it's output current by output voltage. Here the unit is ohm, here it is admittance, the unit is mho. Next we have forward current gain, which is HFB equal to del IC by del IE, keeping VCB constant. And it is current by current, so it is no unit. The value is from 0.9 to 1. And then we have reverse voltage gain HRB. So it's reverse voltage gain. So input voltage by output voltage. So it is del VEB by del VCB, keeping IE constant. So slope of VEB comma VCB curve. The value is from 10 to the power minus 5 to 10 to the power minus 4. Next we shall go for common emitter transistor. So for common emitter configuration, the same way we draw the diagram. Emitter is common or grounded, and we have the emitter current IE going outside. The input is base. The ammeter measures IB, base current which goes inside, and this voltmeter measures VBE, and we have the supply voltage here, which is VBB, and in the output side we have the ammeter which measures IC, which goes inside the transistor. This voltmeter measures VCE and the supply voltage here, which is VCC. So same way we draw the input characteristics and output characteristics. The input characteristics is drawn for VBE and IB the input curve, and for different VCE equal to 0 and VCE is greater than 0 volt. So here when VCE increases, the curve shoots towards the right because of the same early effect, since here we draw for IB instead of IE. And the output characteristic curve is drawn for the output voltage VCE and output current IC. So the curve is like this. There is a small slope compared to common base here, because when alpha changes from 0.98 to 0.985, the current gain of common emitter, which is beta, changes from 49 to 66. So which is a larger change. So there is a slope here in the output characteristic curve. So in this curve, this region is called as active region, where the emitter based junction is forward biased and collector based junction is reverse biased, and the transistor works as an amplifier. This region is called as the cutoff region, where both the junctions, emitter base and collector base junctions, are reverse biased, and it acts as a off switch. Here this region is called as saturation region, where the emitter base and the collector base junctions are forward biased and it acts as on switch. So the transistor applications, as we know, it works as amplifier and switch. And so here again we have the 4 H parameters, which are HIE, HOE, HIE the input impedance, HOE the output admittance, HFE the forward current gain, and HRE the reverse voltage gain. And the formulas hold the same, so we will have to common everything. Here the current gain beta is the output current by input current, so it is IC by IB. So next we go for the common collector kind of transistor, where the collector is common or grounded, the output is the emitter current IE, there is a voltage source. Here voltage is measured VCE. On the output side we have the biasing voltages VE. The input side VBC voltage, current is IB, the input current. And the voltage here is VBB. So here again we draw the input characteristic curve for VBC and the input current IB in microamps. So the curve is like this for different VEC equal to 2 volt and 4 volt, and this is the output characteristic curve for VEC and IE. So the curve is like this for different values of IB. And so same way we have the H parameters, HIC, HOC, HFC the forward current gain, and HRC the reverse voltage gain. The current gain for common collector is gamma, which is equivalent to IE by IB. So these are about the common emitter, common base and common collector configurations. Thank you.